The focus of this video will be on finding x and y intercepts of a rational function. We've done intercepts before, so we're really just changing the function that we're applying the things we already know to. To recall that to find x-intercepts of a function f of x, we find the zeros of f of x by solving the equation f of x equals 0. Remember, we're looking for ordered pairs of the form some number 0. To find the y-intercepts of a function f of x, we evaluate f of 0. This corresponds to ordered pairs of the form 0, some number. So in this example, we want to find the x and y intercepts, if they exist, of each rational function. The first function is f of x equals 1 divided by x plus 2 minus 4. To find the x-intercept, we have to set the function equal to 0, right? F of x equals 0 and solve. We have 1 divided by x plus 2 minus 4 equals 0. There are a few ways you can solve this. We can multiply through the LCD in this stage, or we can actually add 4 and then multiply by the LCD, which is equivalent to cross multiplying. So I will add 4 to each side to get 1 divided by x plus 2 equals 4. Then I will multiply each side by the LCD, which is x plus 2. On the left, that common factor of x plus 2 divides out, leaving just 1, equals on the right 4x plus 8. Now subtract 8 from each side to get negative 7 equals 4x. Therefore, x equals negative 7 fourths. So the x-intercept of this graph of the function would be negative 7 fourths, 0. The y-intercept is found by replacing x with 0. So f of 0 is equal to 1 divided by 0 plus 2 minus 4. This becomes 1/2 minus 4, which is really 1/2 minus 8/2, or negative 7/2. Therefore, the y-intercept is the ordered pair 0, negative 7/2. Part B, we have the function f of x equals x minus 4 divided by x squared plus 2x minus 1. To find the x-intercepts of this function, we set f of x equal to 0 and solve. That gives us x minus 4 divided by x squared plus 2x minus 1 equals 0. If we multiply each side by this LCD, which is the denominator x squared plus 2x minus 1, on the left that simplifies to x minus 4, and on the right 0 times anything is 0, so the x-intercept is 4, 0. The y-intercept, we replace x with 0 to get f of 0 is equal to 0 minus 4 divided by 0 squared plus 2 times 0 minus 1. That simplifies to negative 4 divided by negative 1, or 4. So the y-intercept is the ordered pair 0, 4. And we can confirm this if we actually graph this on our graphing calculator as well. The part C is f of x equals 8 divided by x plus 1 squared minus 2. The x-intercepts are found by setting the function equal to 0. In this case, we get 8 divided by x plus 1 squared minus 2 equals 0. I'm going to add 2 to each side to get 8 divided by x plus 1 squared equals 2. And then we'll multiply each side by the LCD, which is x plus 1 squared. So simplifying on the left, we get 8 equals 2 times x plus 1 squared. Now don't undo that multiplication because we can apply the square root property, which says if we can isolate the squared expression, we can solve for x. We first divide by 2 to get 4 equals x plus 1 squared. So now x plus 1 must be plus or minus the square root of 4, which is 2. Therefore, x equals negative 1 plus or minus 2. So x is negative 1 plus 2, which is 1, and the y value of the intercept is 0, or negative 1 minus 2, which is negative 3, and the y value is 0. Now for the y-intercept, again we find f of 0, and so that would be 8 divided by 0 plus 1 squared minus 2. 0 plus 1 is 1. 1 squared is 1. And 8 divided by 1 is 8. So 8 minus 2 is 6. So the y-intercept of that function would be 0, 6.